Hello and welcome to the second video of our lecture series, Introduction to Programming and Problem Solving. In this video, we are going to look at what an algorithm is. An algorithm may be defined as a step-by-step procedure or set of instructions designed to perform a specific task or to solve a particular problem. A programming algorithm is a technique or a procedure that is used to solve a problem. In the concept of programming, it involves giving instructions or commands to a computer to solve a problem or to fix a problem. An algorithm may also be defined as a well-defined process that takes input, performs a sequence of operations, and produces an output. An algorithm works by having your computer perform a series of prescribed actions that describes how to do something. A programming algorithm may be thought of as a recipe for computers to follow to solve problems or to achieve a goal. Important steps to note in creating an algorithm. First, we know that an algorithm is a step-by-step approach that we take to solve a problem. So probably steps from here to here that we take to get to this destination. That is what an algorithm is. And we are saying that in an algorithm, there are important things that you must note down. First, an algorithm is not supposed to be in a code. So you don't have to write an algorithm in a code form. Here we are saying that an algorithm cannot be written, or you don't have to write an algorithm in a specific programming language, let's say Python or Java or any other programming language or C++. You don't do that. Secondly, drawing diagrams or making lists of processes necessary will be the initial stages in figuring out the design of an algorithm. So we'll be looking at it in details. Representation of algorithms, where you see diagrams or images or figures that we use to represent various steps in designing an algorithm. Thirdly, using conventional tools such as flowcharts and pseudocode to break down problem and then structure a solution. So you look at these tools in details, how you would use these tools, flowcharts or pseudocodes, to break down solutions or even to break down problems in order to provide a structured solution. Fourth, we are saying that you can begin coding the answer only after it has some structure. So you don't just start coding when you have the problem. You sit down, you draft a solution or an algorithm, and then you are going to incorporate those tools, the flowcharts, the pseudocodes, and then from there you begin coding. Okay, so pseudocode. Lastly, pseudocode is the first step toward actually coding your answer because it defines programming constructs without relying on any specific language or syntax. So we look at pseudocodes in upcoming videos. Okay, so essential properties of an algorithm. 1. Algorithms are the recipes that make efficient programming possible. Below are some of the essential properties of algorithms. So 1, an algorithm should be straightforward. It should be very clear, it should be very straight. 2, in an algorithm, there should be no misunderstanding about it. 3, it should result in one-of-a-kind solution to the problem. 4, the solution should be reached in a finite number of steps. It means that an algorithm should have a start and then should have an end. 5, or lastly, it should be able to deal with a variety of unforeseen events. So in writing an algorithm, you should consider different scenarios and then how the solution, an algorithm being a solution, is going to help tackle all those different scenarios. The goal is to have the best possible efficient or effective solution to our problem. Characteristics of an algorithm or traits of an algorithm. Every algorithm must possess the following characteristics. 1, it's supposed to be finite. Here we are saying that an algorithm is supposed to have a start and a finish, basically a finite number of steps. An input. Every algorithm must have many inputs or no inputs at all. Okay. Output. An algorithm should have at least one output. Definiteness. Each step must be clear, well defined, precise. There should be no ambiguity. It should not be cloudy. You should know that this is what you are looking for, this is what you are doing. Right. Effectiveness. Each step in an algorithm must be simple and should take a finite amount of time. Okay, so you can have a step in an algorithm repeating itself. It means that you are never able to solve the problem. You are just stuck at one location. So each step must be finite, and then it should take a finite amount of time to execute successfully. Okay, so let's look at an example of an algorithm. In this algorithm, we are looking at a student trying to get a pen. So here, the problem is for a student to get a pen. The student has no pen, so he needs a pen. So we are drafting an algorithm that is a solution, a step-by-step series of instructions or solutions that would help us accomplish the task of the student getting a pen. So first, step one, we are saying that an algorithm is supposed to be finite, should have a start and an end. So step one, the students, if we are considering the student not having funds, so the student should obtain funds from their parents. Two, considering or having in mind the student being in a house or a facility, the student should leave the house or the facility. Three, the student should keep eye on vehicle movements to ensure safe crossing. So here we are considering unforeseen circumstances. So the goal is to ensure that the student gets a pen. So you must ensure that in getting the pen, the student will not lose the life or anything. All right. So four, if it's safe, the student would cross the road. If it's not safe, you are still here. But if it's safe, crosses the road. If there is a road to be crossed, right, then the student enters the shop, the bookstore, to get the pen that he or she needs. He goes to request the pen, and then chooses a pen from the assortment presented to him by the seller or the bookshop seller or the owner. And then from there, the student makes payment to the shopkeeper for taking the pen. So this was just an example of an algorithm that helps a student acquire a pen. So next, let's look at algorithms and their representations. An algorithm, as we said earlier, is a step-by-step approach of solving a problem, or an algorithm is a step-by-step instruction taken to accomplish a task. The procedures can be described in English than written in programming languages that a computer can understand. Initially, made mention that computers only understand binary language that are zeros and then ones. So we'll be looking at high-level languages and low-level languages in the upcoming series and understand what happens there. Lastly, we are saying that we employ algorithms as part of the planning stage in solving a problem. So you must figure out the steps required to solve the problem before we can create a program to solve that problem. Okay, so the first representation of an algorithm is what we use the natural language for. So the natural language is any language that anyone or any human being can speak. It could be English, it could be French, German, the Akan language, the Gan language. Yeah. So a natural language, as defined, is a popular option since it comes to us naturally and may be used to communicate steps to a wide audience or steps to solve a problem. So an example is what we looked at here with the student issue. So here, this is natural language, and because this is English, and then most people are familiar with English, can read and write English. All right. So the next one is using pseudocodes to represent algorithms. Most algorithms eventually become codes that can be executed on a computer. And then before it becomes codes, programmers frequently express algorithms in pseudocode, which is a code that contains all constructs of a programming language, but does not run. So with a pseudocode, it's not in a specific language format. It is closer. It considers all the principles of programming, which we'll be looking at in our upcoming videos. So a pseudocode is one of the many methods that can be used to represent an algorithm. It is a method for describing the various parts of an algorithm in a way that anyone with a basic understanding of programming can comprehend. Okay, so in our next lecture, we'll be looking at what a pseudocode is, the definition of a pseudocode. Let's look at it in details.